We are now coming to the end of our case study. I want to take a moment to revisit an experiment we did earlier on where, if you remember, we just asked the AI to solve the issue from start to finish. So we're actually going to run that experiment again, but this time we're going to have a lot more context, which we can provide the AI as guidance, and then we can do a before versus after comparison. If you remember, the first time we ran the experiment, we didn't have this context, but now we do. The whole case study has been about coming up with this context. Let's take a look at what that context would actually look like. So this is what our modified prompt with context will look like. The first part of the prompt is the same. We add the context at the end. There's two things we're adding. Number one, we're telling it the relevant files, the relevant part of the code base that the AI should pay attention to. And secondly, we're passing in our root cause analysis. So we're telling it, hey, this is a root cause. If another thread has this lock, the game lock, then it'll throw an exception. We never try again. Our thread hangs forever. We pass that in as context. So, what I'll encourage you to do is copy this. Now, before we run it, though, you are going to want to revert your changes. Okay, so you want to make sure you're in the root directory. Oops, no, pwd is what I meant. So I'm here, and you can do a git status to check which files have been modified. You probably have more files modified than I do, but it doesn't matter. We're just going to do a git restore. Okay. And then to be safe, just do another git status. And you should now see your branch is clean. Now you can ask the AI to do the prompt. Okay. So now you can go to JetBrains. Type in your prompt. Why don't you pause the video here and give it a try? And what I'll encourage you to do actually on your own is, once you have your solution, compare it to the solution you got at the beginning of the video, at the beginning of the case study, and see if you notice any differences. Which solution do you think is better? So I'll pause the video, go ahead and give that a try. Okay, let's walk through the solutions that Copilot generated for me. We'll do Copilot, and then we'll look at Claude. So with Copilot, this first one here, this is Copilot's first solution at the beginning of the case study, when we did not give it that extra context. Let's see what it came up with. I'm just going to highlight one thing here. It wants to create a new dictionary with a separate lock for each game installation. This is needlessly complicated. If you remember, Michael and Alex tried something similar in their earlier attempt, and then the maintainer asked them to get rid of it. This might even be a good idea in the long run to have a dictionary, but it's just not needed for the bug. It doesn't really target the root cause of the bug. All right, so let's take a look at the solution it came up with after we provided in the extra context. So we provide the extra context here, and let's see what it comes up with. So I'll highlight one thing. It's now creating a custom exception for lock acquisition failure. There's no mention of a dictionary anymore. So now it recognizes that there's really only one thing that needs to be fixed. It's quite simple. Just handle the failure better, the lock acquisition failure. Its approach is interesting. It's just going to throw a better exception, I guess. So let's take a look at the implementation. I asked it to implement it, and let me show you what it came up with. it correctly wraps the lock acquisition logic in an if statement. It catches it if it fails to acquire the game lock, and it throws an exception. This exception at least has a better user-friendly error message. So at least it doesn't hang without any message for the user. The user at least knows what's going on. Okay, interesting. In a way, this second solution does a much better job of getting to the root cause in a much simpler way than the first solution. Okay, let's take a look at Claude now. So I'll show you the first solution that I came up with at the beginning of the case study when it did not have the context. So remember, Claude is the state-of-the-art model. So let's see if Claude fared any better than the Copilot without the context. Now, I'm just going to point out one thing here. It seems to think that, see, there's a lot of mention of the UI, the UI. It seems to think the problem is in the UI, and it's not. If you remember, Michael and Alex also initially made that mistake. They were sniffing around in the UI, and ultimately they realized, nope, it's not in the UI. It's in the back end. So Claude made the same mistake initially. Let's see what Claude came up with once we passed in the additional context. So read this sentence here. When multiple apply operations happen simultaneously, the second one fails with an exception instead of queuing up and waiting. That is spot on. It really understands the root cause now. And take a look at its approach. Replace throw on busy with wait for lock. So instead of throwing an exception, it's replacing that with waiting for the lock. And it's correctly identifying the right files and so on. There's no more mention of the UI. It correctly knows where to apply the change and what kind of change is needed. All right, so there you go. That concludes our before and after analysis. I hope that you're convinced that the quality of the solutions that the AI comes up with is way better when you provide more context to the AI, ideally based on your research.